So I'm going to talk about Namenode HA. That's an area of active development in HDFS. And my partner in crime is Suresh. And this is actually a project that is done many contributors, as I'll show you from the community. Look at the current HDFS availability and data integrity. What have we focused on so far? We focused on a very simple design for HDFS, and most of our efforts went into storage fault tolerance. Okay, so we rely upon the OS file system rather than use the raw disk, and so we get a pretty robust low-level storage, and also gives us freedom to move to ext4 or ZFS or any other things that we like. We are focused on having multiple replicas of the data, and actively monitoring those replicas and making sure that those replicas actually get replicated when there's a missing one. And we've also done a lot of statistical calculations on how that it's important to go and make this replication management done actively and also done promptly. So that's been a very important area. The Namenode, however, has been a single master. It does actually store all its state on multiple disks, okay, and you can configure how many disks you want. And it is very typical to configure one of the disks to actually be remote, so that if you have a catastrophic failure of your Namenode box burns up and all its disks burn up, then you have a copy of the data available on a different disk that is remote, so you can actually have multiple checkpointers that are edit logs that are being written in parallel. And when you restart, the Namenode actually recovers all its data. It does not lose any of its data. And so this has been the approach. And so how well did this work? We did a study at Yahoo in 2009 on about 20,000 nodes running on approximately 10 clusters. Okay, these are production clusters that are in use at Yahoo, and these used to hold about 330 million blocks. And in 2009, we lost about 650 blocks total. Okay, there's 650 blocks out of 330 million. And we did an analysis of why we lost these blocks, because even if it's such a small number of blocks, it is not good enough if it contains your data, clearly, right? So 82% of these were actually because a file had been abandoned, and we actually had a bug in the first version of Append where the system could not automatically figure out that these blocks were from abandoned files and they should ignore them. So it turns out it reported them, but these were actually files and blocks that had been abandoned. This has been fixed in release 22 and 23. Okay, and so this was really a bug in reporting, not a bug in the actual system itself. We had 15% of these files were created with a single replica, which means that the customer didn't care about the reliability. He explicitly wanted a single replica because he preferred the additional performance advantage of a single replica. And 3% of those were 2 to 7 bugs that were promptly fixed. So it's a pretty impressive record on data integrity. Okay. This compares with the best out there in various systems. Then we started to look at the failures of the Namenode. So over the last 18 months, we had a total of 22 failures. By failures, I don't mean just in the lot. Maybe too loud. Is that okay? You can hear me? Okay. So we had 22 failures. By failures, I mean unplanned downtime, where either the machine died or the service died or something happened. Okay, this included things like if you had a single NIC and you had a NIC failure, or if you had a switch that wasn't, things like that, or power failures. Of these that we looked at on 22 failures, only about 8 of these would have actually benefited from an HA automatic failover. Okay. Some of them, for example, if you had a software error or a bug that occurred right over when the system started because of some new software we put in, then it would be reported also on the failover backup Namenode if you were to fail it over. And so these were 8 failures. That's about 0.23 failures per cluster year. Okay, and the name node is actually very robust and it can take a lot of abuse. Okay, we've seen this on our work at both Facebook and at Yahoo. But HA is something that we are working on. So I'm going to give you some feedback, some information on what's happening in 23, and then I'm going to completely focus on our HA design. Okay. So some improvements that we have done in the upcoming release, release 21 and of course now 23. The append flush sync thing has been completely redesigned, re-implemented. Okay. So for example, those 85% of the problems I told you about, which were mistake reporting of the abandoned blocks, would not happen anymore, would not be reported because it detects it. There's a pipeline improvement that has been done in 23, much faster HDFS startup. So this is a bounce time of 20 minutes on a cluster with about 300 million objects. Okay, federation of course allows smaller name nodes because of federation, and so and also now lets you isolate applications that are the namespace of particular applications in a separate volume if you like. So it lets you allow you to do that. So now let me get to the main topic of here and kind of give you a quick overview and then give you some detailed design and let you ask some questions. We've done a detailed design that we published in the Jira HDFS 1623. This was actually received well by the community. They looked at the design, they liked it, and in fact a number of the members of the community, folks from Facebook, Cloudera, and eBay, are all actually participating in this design in the Jiras, and these are the sub-Jiras that are listed over there. So active work is actually started on that. And a number of prototypes have been built. So the most important one, of course, is the avatar name node. I shouldn't call it a prototype. This is actually being used in production at Facebook. And they mainly use it for actually failover during upgrades. So they use it for failover during upgrades because they find that the name node actually doesn't die on its own. It's usually doing an upgrade where you are actually doing maintenance. And they want a fast failover, a hot failover. And that's where they use it. We did a backup name node, which is part of our design in 21. At Yahoo, we did a prototype of HA name node using Linux HA. Okay, and eBay Constantine has done a prototype with a backup name node and a block report replicator. Okay, and all of these actually fit in well with the overall design structure that I'm going to explain a little bit more. Okay, so let's get to the meat of it. So our initial goal is really to go with active standby. So we're not doing active in this initially. If you are using federation, which allows you multiple volumes, then it means that you actually have a distributed name node, a name service, sorry, distributed name service, and each partition, each volume can have its own master that is active. So you will have multiple active name nodes, but each of them are serving only a portion of the namespace. But for any portion of the namespace, there is only one name node that is active. Okay, that is the initial design goal that we are focusing on. So some quick terminology. This is pretty standard. Active name node is the one that actively serves read-write operations from the client. Standby is the one that waits, becomes active when the active dies or is unhealthy. It could serve read operations. In the first version, we're not going to focus on read operations from the standby. Okay, the standby state may be cold, warm, or hot, and we are focusing on hot standby where it has loaded all the FS image. It is continuously loading the edits, okay, and that it actually also has processed all the block reports. Okay, so it is fairly close to being hot. So high-level use cases. So for planned downtime, things like upgrades, config changes, which is usually been the main reasons for downtime. For planned downtime, unplanned downtime, things like hardware failure, server is unresponsive because it's got some issues, software failures that are non-repetitive, and these, as I showed you from the statistics, both at us and at Facebook occurs infrequently, but we're addressing this. We're not dealing with double hardware failures, okay? So, you have to, for example, configure dual switches or dual NIC cards, things like that, okay, which is pretty standard. The deployment models that we will support is that you can continue to have a single name node configuration with no failover. That means the current usage model would of course have to continue to work, because there are people who may not, may have a lightweight implementation or testing something they don't care about the HA. Then there will be another one which is active standby with manual failover, and this will be available earlier. And then active standby with automatic failover with hot standby. Okay. There are more detailed use cases in the Jira. There's a pretty detailed document there that talks about this. So give you kind of overall design focus that we have is that the failover control is outside the name node. Okay, this is pretty much very standard for a lot of systems that you've seen in the industry. I'll explain what that means. So it's really not the name node who's making the decision on the failover. There is actually a daemon, what we call the HA daemon, that's doing that. That's very common in a lot of clustering solutions. We will be sending parallel block reports to active and standby. We actually support both shared and non-shared name node state. For example, the backup name node is non-shared state, or we could use a shared storage system. And I can explain to you some of the options that are available over there. And anytime you have fencing of, anytime you have shared data, shared resources, you need to make sure that during failover, there is fencing. In case of split brain, what you don't want is two masters to think that they are in charge. Even if it occurs very rarely, you can basically corrupt data, and in fact you will have a downtime that is bigger than not having failover. Okay, so fencing is a pretty important thing. The places where we do need to do fencing is the data node itself. It's a shared resource, and one of the areas where you can run into problem is that you could have an active make a decision just before failover that is going to remove, replica number 4 because it's excess. When it fails over, the other secondary could make a decision, no, I'm going to get rid of replica 3 because it doesn't know the other one did that. And so you have to make sure that only one is allowed to do an update at any time, and there's a control that is passed over correctly. And if you are using a shared name node state, which as I mentioned to you, our design will support both models, then you need to make sure you share, you fence the shared name node state. And then of course there's client failover. We are right now not made a firm decisions on IP failover versus using a smart client, such as using those two people to have the client detect that control is transferred from active to standby. Okay, so we've not made a firm decision on this one. The main thing about the issue over here is that IP failover is pretty standard in the industry, but in Hadoop it causes one challenge, and the challenge is that IP failover really works very well in a subnet, and if you're doing across subnets, then you need to do use VLANs and do spanning algorithms. Okay, so it is more complicated network environment. The thing that is usual in Hadoop deployments, not all of them, but it's not uncommon, is that people have racks of servers. Each rack typically has a switch on the top, and each rack is in a separate subnet, and therefore it's very practical to put your name node on one rack and the standby name node on another rack, which means they're on different subnets, which makes IP failover challenging. If you are to do IP failover, you will make sure that you actually have them on the same subnet with a disk and do a failover within that subnet with multiple switches. So that's one area that we haven't made a firm decision right now. You'll see the progress on this on the Jira. So let me talk about the first thing I mentioned, HA control outside of the name nodes. So the idea is that and this is very common in many HA systems, that you have a kind of an HA daemon, and the HA daemon does a number of things. It is monitoring a set of resources. One of the resources it's actually monitoring is the name node itself, or the service that it's trying to fail over. But it actually can monitor many things. Just to monitor, for example, is the OS healthy? Is the NIC card to the external world healthy? Has it got enough swap space? Various things like that. And then it takes certain actions like starting and stopping. So we start the name node or stop the name node. It has to do fencing when it fails over. Okay, one of the common fencing things that people often use is Stone-If. That's what and of course the most important thing it does is leader election. Okay, and we've left this outside of the name node. because what it does, it keeps the logic of the name node to focus on the name node and keeps the logic of failover and the coordination of actions and the sequencing of actions to be outside. It also means that you do need something to monitor that the name node is healthy and all that. So this is pretty classic. If anybody has used Veritas cluster or Sun cluster or Linux HA, they all have such a daemon like this. And so for example, we could easily use the daemon from Linux HA. And we build a prototype based on that. So here is, for example, the overall picture of how you would look with, say, Zookeeper. Okay? And so there would be a failover controller, there would be an active who would monitor its health, it would monitor the network, and would issue commands to the active periodically when it needs to. And you see on the bottom what's happening is the data nodes are sending their block reports to both the name nodes. In this particular configuration that I've shown is we are using a shared storage for the name node. Okay, and this one, clearly one of the challenges here is that you have to buy an NFS server to do this. Okay, it's easy to get it up, but one of the things we are looking at is Bookkeeper down the road. And so for Bookkeeper, this would become a very, very attractive solution because Bookkeeper provides a very high-speed logging mechanism. Okay, so you can write edit logs at extremely fast, faster than a local disk. And it already has we're working with them on getting a fencing mechanism built in. So really this one we want to get working because we see Bookkeeper as a very, very attractive solution down the road. So Bookkeeper is kind of a sister technology to Zookeeper. In this particular case, I've shown that Zookeeper is the one to which you do heartbeats and does the lead election. Okay. Let's see, anything else I want to say is, on the data nodes, as I mentioned before, you have to have fencing for the commands. Okay, otherwise you will have two masters. This is how it will look, for example, if you want to do the same thing with Linux HA. If you want to use Linux HA, this is how the picture would look. The main thing I've changed here is that I'm no longer using Zookeeper. Linux HA also has the notion of a quorum device, and in fact you could use Zookeeper as your quorum device. In fact, what happens is Zookeeper then becomes the lead election. Okay? So this is the model it will look as. Quick one on shared versus non-shared. I will explain you the shared one. And for the non-shared one, we have a backup name node. And therefore, that's the bottom picture. So the active name node is actively streaming its edits to the backup name node, which is the name node on standby. And they would have a local disk. And that is one use case we've identified in the document that is a challenge when you actually have your active actually being down, has been down for a while, and now you want to bring up the standby as the new active because somehow you failed to bring up the old active. Where exactly is the latest state? Okay, so that's one of the use cases that is a challenge in this one that we are discussing in the Jira. Let's see. That was kind of about it on the overall design. There are patches already available for some of the sub Jiras. Okay, that one of them 107.3, which is not quite completely tied to HA, but it was very important for us. In dealing with our edit logs. So it was some cleanup we wanted to do in the edit logs, which is almost pretty ready to close. So that one is almost done right now. Okay, but there's work that is happening on various, and I also want to acknowledge that this is a community effort. We've come to an agreement on the overall design in the community. And if you go and look at the Jira, I'll tell you, show you people from Hortonworks, Yahoo, from Cloudera, from Facebook, and also from eBay that are participating. So, we're all behind the overall design, and this is going to come out very soon, and it is one of the highest priorities for us. Any questions? The failure scenarios. This one. Oh, the actual failure, excuse me. Yes, sorry, sir. I got it. Excuse me. Okay. This one. So we looked at each of the failure cases. Okay, so for example, there was one where we had a complete cluster power out. Okay, and therefore both your active and standby would have both died. Okay. There were several of them where we had just introduced a new version, a new dot release, and as soon as the name node started, it died because there was a bug that had not been caught in QA. And if you'd done a failover, the standby would have also died right away. Okay, so this was right after bringing in new code. Okay, I'll give you an example of 4 of them that actually would have benefited. We had 4 cases where actually the name node was not responding. We didn't know why. We restarted the name node and the problem disappeared completely. Those 4, for example, would have benefited from a failover because the standby would have actually recovered. The other ones that would have benefited was there were cases where we had a hardware failure on the machine. The second one where the machine itself failed. There's another one where we had a memory error on the machine and the machine died, and that would have also helped on the failover. Okay, so those were the ones that would have all worked on. Okay, and this was 22 failures on 25 clusters. Okay, so in 18 months we are getting less than. So this is unplanned downtime. You're getting less than 1 failure per year. Okay, of this, a number would have helped from HA. The other benefit that I want to kind of stress for HA is that also it means that your upgrades become faster because you're not doing it on a hot name. Okay, so even though these 8 would have benefited, HA would benefit on an upgrade.
How does the avatar implementation working now currently differ from this solution?
Okay, so the Dhruva and Dimitro, who are actually the authors of Avatar Name Node, they're actually also active participants in this. Okay, so what Avatar is being used for is what they've done. Okay, is that they've put a wrapper around the data node. They've put a wrapper around the name node. Okay, so they did not have to go and change massive code changes in the tool. The wrapper of the data node sends dual block reports. Okay, and what they do is in order to do the fencing, for example, okay, they rely upon a timeout, and they say, well, within this timeout, if we do not do any replica deletions, we are sure that there won't be a problem. Okay, it's not a guarantee, but it is actually for practical purposes correct. What we are doing here is identify the correct problem, but actually fixing that correctly in the data node itself is one example. Okay. Second example of how it differs is that they are putting a wrapper around the name node, because what you want is the name node, normally a name node only knows how to start in an active mode. Okay? So they have to put a wrapper around it where it says you are active, in which case it does the normal name node. And if you're passive, standby, it actually puts it into a safe mode, which is not really a standby mode. In their safe mode, what they do is they have a special, they're putting the code to go and read the edits from a shared storage. So they periodically read the edits, they're getting the block reports, and so their goal was to do a warm to hot failover. Okay? What we are doing here is we are actually putting inside the name node itself, okay, a notion of that when you come up, you have states. State is called standby or active. You always come in standby. Then somebody tells you, okay, which is our HA daemon, to actually become active or to go from standby from active to standby. Okay, so basically this is much cleaner. It's put inside. So in some sense we are reusing that design. Okay, in the case of fencing, okay, we are looking at fencing in a much more serious way. So they basically on their shared node failover, because they're doing manual failover, they do not have to worry about fencing of the shared storage. Okay, that works very well for a manual failover. It does not work for a non-manual failover. Okay, so those are some of the differences. Our model is also slightly more general to use the backup name node where you have nothing shared. Okay, another change is that we, as part of 1073, which is edit logs, and a sister Jira that Jitendra now at Open Industry at Yahoo, and one of our colleagues in Yahoo Barcelona, they have actually gone and cleaned up the journaling interface so that you can do a number of things. You can plug in Bookkeeper into the picture, okay? And what that does, it gives us an edit log that is shared. It also gives us an edit log that automatically has built-in fencing, and one that is extremely fast. Okay, it is faster than having multiple disks. Okay, so those are some of the areas where we are, making an improvement. There are not so many ways to do HA. So yes, we are extending on some of the avatars work, learning the lessons that they have got. There was actually one other difference. I can't remember now. It got in my when I was telling you. It was in my mind and I forgot it now. But that's the difference. So we've got actually complete agreement from the Facebook team that did Avatar, and so they're active participants in this design, which we are very happy to help them on. Any other questions?
Questions? No? High availability of the name node. No questions? One more? There's too much redundancy in here. You guys all think like, nobody's asking any questions.
At the beginning of the presentation, but just wondering the reason why we have only active and standby, one active and one standby.
Why not active?
Yeah, instead of a set of like group federation that, according to some algorithm, would elect the next active.
So let me clarify two things here. So the question that he asked was, why are you doing active standby? Okay. Why aren't you doing, first of all, active, and why aren't you doing active with multiple active masters, correct?
With some election.
Based on election, right? So the main kind of reason is that based upon federation, you already have the namespace that is partitioned, okay, into volumes. At any time when a name node dies, you only lose a portion of the namespace. So you already have, in a sense, a multi-master partitioned namespace, okay? So right now, even with release 23 without HA, you only get partial failures, you don't get full failures. And because of client-side mount table, there is no single master name node on which the mount points are. Okay? So we felt that we already have multiple partitions. The second reason why we did not do active is that we already seen that we're getting pretty low failure rates. Okay, and doing active standby was actually the fastest way to make this work. It was very little code change. Okay, and so we can get this out in matter of 2-3 months of work. Okay, we've done a very detailed design. So this was the fastest. The design we have done does not exclude to do active if somebody wants to do that. It does not exclude that. Okay, we believe a large part of the machinery like fencing, like duplicate block reports, all of these would actually be equally useful. But we just didn't warrant going into a much more complicated project. Okay, and so that was the only reason. We just want to get something out. It does not exclude us doing something like that down the road. Okay. So that was the main reason for that. Any other questions? Or
when is this going to be available?
We want to get it out within about, we believe that we'll have the code ready within about 3 months. Okay. And so really right after 23, we are not going to, I have to say this because you are the guy who's driving the internal deployment inside Yahoo. So we don't want to actually risk the 23 schedule at all. Of course, as engineers, we think this code is very little changes and should be put in the last moment, but those are usually famous last words of every engineer, right? So we want to get 23 out, get that rolling, get that through the stuff. At the same time, we're going to make this available, and I would like to call it 23.1 or 2 or X. Okay? But as far as what release we got, that's the decision that the community makes. Okay, on what release to call it out, etc. But you got complete sync in with the rest of the community.
Any other questions?
No, it's an independent company.
Repeat the question.
He was asking, is Hortonworks, why is Hortonworks the hottest company around? Is that what he asked? No, I didn't ask that, sorry. No, he asked actually, is Hortonworks a wholly owned subsidiary of Yahoo? No, it's not a wholly owned subsidiary of Yahoo. It has got investments from Benchmark, for example. We are working very actively with Yahoo in both development, in testing, in deploying, so that the release of 23 that comes out, any other dot release of 20.203, 204, 205 that come out, will have the same rigorous testing that you've always seen on every reliable, stable release of a tool. Okay? So we want to make sure that as part of this, there's no regression in the quality. The statistics I showed you in this page about data integrity and all that, we want to maintain that. We want to continue to maintain. In fact, the level of testing that we are doing in 23, the automation we've done is way beyond what we did in 20. In the original 20, 2 or 3, of course, does the same. So that we are continuing, and he manages part of the release process and the quality process at Yahoo. So yeah, we are definitely partners in multiple ways.
Right, as Sanjay pointed out, Hortonworks is a development partner for us. So what they're building on is ultimately getting deployed on 40,000 plus nodes with 200 plus petabytes of data. If it works at that scale, it probably will work for use cases also. Not guaranteed, but most of the times it will. And we are working with these guys, and we look forward to having good partnership with them even in the future beyond 23 and engineering.
And one question, a little over here. Do you guarantee consistency between the primary and the secondary name node, or okay? Yeah, I think it was almost in the hot failover.
No, so okay, yeah. Let me clarify the question. So the question he was asking was, I had said somewhere, let me see if I can find this slide. Basically, I'd say that the standby is, can be cold, warm, or almost hot. That doesn't mean it loses data. So the difference between cold, warm, and hot is how long it takes to become active. Okay, the name node has to come in a consistent state. Sorry, the standby has to come in a consistent state with what the active originally was. The speed at which it comes up is whether it's how cold or warm it is. Okay, clearly, even if it has all the data, it is always going to finish a little bit more work as it comes up. So, for example, if you are using shared storage for the edit logs, it would be constantly reading. When the name node dies, you may not have finished reading everything, so you might take a few seconds. So it's not, I would not classify it hot. If you're doing backup name node, then actually everything is synchronously sent, so then it is truly hot. Okay, but yeah, there is no loss of data or consistency to maintain the same quality that we have today. Otherwise, it won't be acceptable. I mean, then HA would be actually worse than not having HA. Yeah, absolutely. Yes.
Your diagram showed just one standby, but does your design allow for more than one standby?
Does our design? Yeah, I believe our design actually does not exclude multiple standbys. In fact, the question that most people are asking us is a different question. They ask us if I have n actives for different portions, do I need to have n standbys? Why can't I have normally what people want is, k plus n, right? And we haven't figured out how to do that if you want to be hot. If you want to be cold, then we can do that. Okay, but I don't think of a design, let me see if it allows multiple standbys. I don't think we exclude it, but let me think about that and get back to you on that. I don't believe the design actually excludes that. But most people are usually happy with a single fault. Okay, any other questions? Okay, thank you very much.
Thank you, sir.